Today, we're going to dive deep into a really cool IoT-based smart mobile charger. This is an engineering project that was designed to solve a problem pretty much all of us have, overcharging our phones. We're going to look at the hardware, the software, and most importantly, the step-by-step data journey that makes it all work. Let's get right into it. So, be honest, how many of you plug your phone in before bed and just leave it charging all night long? It's a super common habit, right? And even though modern phones have some safeguards, letting it sit at 100% for hours on end isn't exactly great for it. But what are the actual downsides of leaving your phone plugged in for too long? Well, it turns out there are a few hidden costs. First off, you're wasting energy. The charger keeps sipping power to trickle charge a battery that's already full. Second, this whole process generates extra heat, and that can slowly degrade the battery cells, which ultimately shortens its lifespan. And while it's pretty rare, faulty parts can overheat, which is a potential safety risk. This project, though, it aims to tackle all of these issues head-on. So how do you take a regular charger and make it, well, smart? The secret ingredient here is the Internet of Things, or IoT. This is the technology that transforms a simple power cable into a responsive, automated system that can actually think for itself. At its heart, IoT is really just about connecting physical objects to the internet so they can talk to each other. In this project, it creates this really simple but powerful little network. You've got the charger hardware, which talks to a cloud database, which then syncs up with a mobile app. And boom, this connection lets you monitor and control the whole charging process in real time from basically anywhere. All right, so to make all this communication happen, you need a few key players. Let's meet the different hardware and software components. These are really the brains and the brawn behind this whole operation. Okay, so this is the core hardware. That little black chip you see, that's the ESP8266 microcontroller, and it's basically the brain of the whole system. Right next to it, you've got that blue box. That's the relay module. Think of it like a remote-controlled light switch that can physically turn the power to the phone on or off. Together, these two pieces form the real heart of our smart charger. And this table just breaks it down perfectly. The ESP8266 is the brain. It's got Wi-Fi built in right in, and it makes all the decisions. The relay module is the switch. It does the physical work of turning the power on and off. Then you have Firebase, which is the cloud, kind of like the central meeting point for all the data. And finally, the mobile apps are the interface, which is your window for seeing and controlling everything. All right, now we're getting to the most important part. Let's actually follow the data step by step to see exactly how this whole system works together to stop your phone from overcharging. This is where the magic happens.
So this diagram gives us the bird's eye view of the system. The whole journey starts at phone A. That's the device that's actually being charged. Its battery level gets sent up to the Firebase cloud. Then, the ESP8266 hardware, our brain, pulls that data down from the cloud, makes a quick decision, and tells the relay what to do. Now let's break down each step of that journey.
Okay, let's walk through this whole smart charging loop. Step 1. An app on phone A, the one plugged in, reads its current battery percentage. Step 2, it shoots that percentage up to the Firebase cloud, and it does this in real time. Step 3, now on a different phone, let's call it phone B, the user opens up a control app and sets a charging limit, let's say 80%. That number also gets saved to Firebase. Using a second phone is what lets you monitor and control things remotely. Step 4, our little ESP8266 brain connects to your Wi-Fi and fetches both numbers from the cloud, the current battery level and the 80% limit you set. Step 5, it just sits there constantly comparing those two values. And finally, step 6, the second that the battery level hits or goes past the limit, the ESP8266 sends a signal to the relay, which then flicks the switch and cuts the power. And the key thing to get here is that this isn't a one-and-done check. It's a continuous feedback loop. The system is always watching, always checking, which means the charger responds the very instant that target is reached. Okay, all that theory is great, but let's make this even more real with a practical example of how the system works when it's all hooked up. And here it is, the working prototype. The phone over on the left is our control device, phone B, and it's running the monitoring app. The phone on the right is phone A, the one getting charged. And right in the middle, you can see our little circuit with the ESP8266 and the relay module just controlling the flow of power. And this little table shows the decision-making perfectly. So when the phone's battery is at 60% and our limit is set to 80, the relay switch stays on, no problem. Charging continues. But the instant that battery level ticks over to 80%, the ESP8266 sees the match, sends the command, and the relay switch automatically flips off. Power is cut. Mission accomplished. It's that simple. So now that we've seen the nuts and bolts of how it works, let's zoom out a bit and look at the key features and the real advantages that a system like this brings to the table. The project has several really great features built in. We've already seen the automatic power cutoff and the remote monitoring. Of course, you can set your own custom charging limits, which is great, but it also goes a step further. It's designed with an integrated billing system. This could actually track how long a device was charged and calculate a cost, which makes it a really interesting prototype for, say, public charging stations. And those features lead to some really tangible advantages. Preventing overcharging directly helps your phone's battery live a longer, healthier life. It saves electricity, which is great for your bill and the planet. It makes things safer by reducing that overheating risk. And like we just said, that billing feature makes it totally scalable for public spaces like airports or coffee shops. And we're not talking about tiny, insignificant savings here. The performance tests on this project showed that by cutting out that unnecessary trickle charging after the battery is full, you can save between 20 and 30% in energy. That's actually a pretty big deal, especially if you imagine that scaled up across millions of devices. A project like this is a fantastic demonstration of how IoT can improve the simple objects we use every single day. It takes a process we do without even thinking about it and makes it smarter, safer, and way more efficient. So what does this tell us about what's next? I think this quote from the project's own conclusion just says it all. The system successfully automates power control, enhances safety, and cuts down on waste. It's a perfect case study showing that IoT isn't just some big, complicated thing for factories. It can make a real, practical difference right in our own homes. And that really leaves us with a final thought to chew on. We've seen how a simple charger can be made smart. So, what's next? What other common device sitting in your house right now is just waiting for a simple, effective IoT upgrade? It's a pretty exciting question to think about. Thanks for diving into this explainer with me.